Daz. Well, I've got the Ultra out again, and hopefully do some more work on it. Finish recapping it, perhaps even clean the chassis, clean the valve holders, lubricate the capacitor, check the rubber mounts. I think they've perished. Think about what I'm going to do about the metal oxide or selenium rectifier, whatever it is, and go from there. I actually have been using my soldering gun. I needed a bit of extra heat. Well, I'm just progressing through. I've put the 47s here underneath the chassis adjacent to the IF valve. They're only 63 volts, even after what I said about them possibly getting overvolted if you had an open circuit filament. I'm not going to worry too much. I'm also decided to replace that Hunt, which was the coupling capacitor for the local oscillator. Also this one here, which is for the input to the mixer valve from the what would you call it, frame aerial. Obviously, because of the very high resistance of the AGC, if that leaks, that's going to drain the AGC away or otherwise affect it, so I've decided to replace that. One of my viewers kindly said that they do suffer from resistor drift in here, and I have replaced a few resistors, a couple of 1 megs and also the 150k here, which that one had risen 30%, and so the 1 megs. But interestingly, a lot of the other ones are actually within 10% still, which I can't understand. That this is so unpredictable. But one interesting thing is when checking the resistance of the shunt resistors, obviously you need to take the valves out because the filaments are shunting the values. That did cause a slight confusion until I remembered to pull out some of the valves. So making quite good progress at the moment, so I'll just continue along. Here's one of the high value resistors, and I'd expect this to have drifted more. It's a 4.7 mega ohms, and it's only up to 5 meg, so I'm really surprised. And this is the bias one for the AGC. What's that? 5.6 mega ohms. It's 5.8. So I am really surprised at that. Here's the coupling capacitor, 500 puff for the input to the mixer valve from the frame aerial, and yeah, you can see even at a few volts from this meter it's reading 14 megs, and that's enough to upset the biasing, I'm pretty certain, from the AGC. If you remember, it's got a bias from the 7.5 volt rail to pull it positive, and I'm pretty certain that would cause problems. Just going to clean my valve holders now. I'm using what you clean your teeth with, these little brushes. Just thought that might help get the oxide down there. There we go. Just remember not to use them to clean my teeth now. Yes, this is a bit of a pain in the neck. Once I realised you pull the bit of paper out, it does make it slide in the spring a bit easier, but yeah, they've not left any real length here to pull the spring back off. So just powering up the low tension side. We've got 7.3, and here's that bias voltage, about 1.44. I expect a little bit higher because this meter is 10 meg, so it's loading it a little bit, I guess. But yeah, so that's the bias on the AGC. Okay, just set up the HT now. Now there's the low tension. I've got 7.3. It's drawing about 60 milliamp. There's the HT. Let's wind that up. Oh, we have noise. Near enough. I think we have a lot of noise on the bench, but No, that was long wave. Oh yes, we've got Caroline, so it is receiving. So let's have a look at the AGC voltage here. If I just tune across a few stations, you can see it going down towards naught. That's quite a weak one. Find a more stronger station. Oh yeah, it's going down to half. If I go to my local station, well, it's gone minus now. I was curious to see how much volt drop was across this metal rectifier. At the moment I've got about 120 milliamps flowing through it, and it's about 42 volts. Of course this is half wave. I think the total HT is about 65 milliamps because of the filaments, and of course it's half wave, so you're only charging up on a half cycle, so it's at least double that. Plus you've got the fact that it's only charging up on the crests of the waveform, so I reckon that's quite generous for the current that's flowing through there. But 42 volts is quite a big drop. Yes, it is nearly 70 years old, this rectifier, so it may well have gone higher resistance, but it's quite interesting to see the volt drop there. And indeed, oh yeah, that is warm, quite warm. Now you can see the reason for the fins. So I guess I'm going to put silicon rectifier in. I'll need to put another dropper resistor in to account for this, so I guess that'll be the next job. Well, I've just taken the stack off the bracket, and I didn't realise it actually all come apart. So you've got your bolts at this end and the connector, an insulator, there's an insulating layer there, and I guess this is the actual plate, or the oxide part that makes contact. It's quite corroded, so yeah, quite interesting. For a bit of fun, giggles, let's just see. Oh, look at that, 0.3, open. There you go. So that's not a very high volt drop, but of course the meter's not putting much current through it. I'm just rebuilding the power supply here. I'm using one of these resistors, Polo Mint they're known as, I think. I found some in my box, so I've just got the cross the line capacitor here, put an X in, the usual 1N 1007, and I've used one of these resistors. Now I was wondering about these resistors, why they're like they are. They're sort of marked with a current rating and an unusual resistance, like that one's 200, this is 250 ohm. And I was watching a video on Andy Doz's channel, and he had a Pi television, and these were strapped across, and I've now realised that these resistors were used for repairing sections on these resistors. Something new I've learned. Just have to see how this 200 ohm works. I need to look at the HT and the low tension and see where they come. I'll soon find out if I'm in the ballpark. I haven't got any fibre washers, so I've had to use a couple of spring washers. I hope that's okay, doesn't crack the ceramic. I'm trying to think where I got these from. I think an amateur friend gave them to me. Sure that meets modern safety standards. The only thing I found is this, really the right colour, but yeah, adds a bit of interest, doesn't it? Don't think I'm going to get a modern 13 amp plug in there. I guess that was for a 5 amp or 15 amp round pin. Yeah. Interesting, you can plug it in either way, so you can have a live or a dead chassis. Yeah, a bit like the DAC 90A I've got, isn't it? Yeah. Of course, this looks like this could be quite fun. Of course, then you could use cable like this with just one insulation layer, but now, of course, you have to have double insulated cable, so it'll be interesting to see if it goes in. Might as well clean the contacts while I'm here, I guess. When they go in, but I think this is going to go together. I'm going to have to mark this plug, I guess, which way is up, so fair enough. Don't think that really works, does it? It's a novel design anyway. I guess that's why the cable was extended in the first place, because I guess even with this original cable you couldn't get an awful lot of it round there, but obviously with the modern double insulated cable, plus I've got this cotton on it, I think that's definitely not going to work very well, unless I only want it as a very short lead. Nope, that's not going to happen, is it? As you can see from the meters, I'm just bringing the mains up for the first time to the receiver to see what we get. That's the current HT voltage, and this is the current filament voltage, which is very low, but of course the filaments are cold and they alter as they get hotter, so this may go up. I'm at 25% at the moment, so I'm going to bring it up to 50 and see if any smoke comes out. Now got about 48 volts on the HT and about 2.1 on the filaments. 60%. You can see the filament is rising. That's 155 volts. My meter's now become active. A bit more. 178. And the voltages are coming up. Still rather on the low side. 80%, 204 volts now, so we're now cooking with gas. Nothing appears to be smoking at the moment. Of course I am running through an isolation transformer, as this is a live chassis set. Let's bring it up to about 230. About 230, I can hear some pinking, so something is probably getting hot. So the HT is nearly 85, but the filament voltage is a bit on the low side, I would say. So it might be my resistors a little bit too much. Oh, it's getting warm, but only slightly. So I think I'll need to have a think about this and see if I need to make some adjustments. Okay, so this is the final voltages I've got. 85, HT sounds fine, but filament voltage 5.7, that's really too low. The valves are designed for 1.4, so I would have thought a good 7 volts would be about right. Now, why is this? Well, I thought I checked the resistors and they were fairly accurate, but I think I'll recheck them again. Now also, the data sheet, or the trader sheet, tells me that I should have 215 on the first smoothing capacitor, so let's have a look at that. Okay, we have 218 volts at that first capacitor, and that is right. So that's about right. So that 200 ohm resistor was a very good guess. So we're very, very close to what the data sheet, or the trader sheet, was telling us. So why is the filament voltage so low? Well, that's the 355 section, 360. That's the 405 section, which is 405. And this is the main part, I guess, the 260. 262. This is the HT dropping resistor, which is 1420, 1406, and the filament dropper should be 1650, and it's 1654. Oh, okay, so everything is quite normal there. Did they design it to only have filament voltage of 5.7, but it seems awfully low to me. Well, I've looked up on Google, or the internet, whatever you want to call it,
And there has been a discussion on voltages for filaments on a number of forums, and conclusion seems to be around 675 is about the maximum you want to be. And to be honest, where I'm looking at the moment, 1.1 is a bit on the low side. I did check the voltages across the string. Some valves are slightly lower than others, but they're pretty well balanced. So I think the best thing I can do is put a little bit of shunt across the filament, this one, isn't it? The filament resistor, and just see if I can or was it that one, and just see if I can bring it up a bit. Okay, so what I've done is I've added a 1k resistor across my 200 ohm, which was the extra resistor in lieu of the metal rectifier, and I've put a 15k across the dropper for the filaments, and at 241 volts I have 6.3 filament now. And an HT of 82 volts. I think that's probably about the best I'm going to do. My isn't this sensitive to change of voltage. Let me just turn this down to 230. You can see the filament voltage has now dropped to 5.9. And the HT to 78. That is really sensitive. If we turn the mains up to approximately 253, which is as high as I believe it should go now. It's 6.6, so it's still not too high, and the HT is 84, so it won't go over volts, but it's a very, very delicate balance, I think. I think my mains is normally about 242 here, so let's dial that in. That's enough for the filament, that's fine, it's not overrunning them, and even when the mains is high. Okay, so I want to change the rubber supports on the pot, so I'm just looking at how the string is done. I guess the idea is to take the spring off and put a mark on here, so I can put this back where it was, and hopefully not lose where the scale was. Basically there's a screw and a washer, and there's a small brass insert in the rubber grommet, so I've just managed to push this one into the replacement. It just pushes in the capacitor. Drop of oil in the bearings while we're here. Hopefully make it run a little smoother. I'm now stripping down the case. Removing these pegs is not my favourite job. I'm always frightened of breaking something, so it's a case of just carefully levering the spring and hoping I don't break something. There we go. You know, you've got two springs, and obviously they're designed to not allow it to come back off but push on. I just don't like them, but I need to figure out how I'm going to get this plastic to sit down properly. The answer might be there when I've taken it apart. Well, I still have all the pegs, so obviously this one was the badge, and it's interesting because I thought plastic shrunk, so what has happened here, I wonder? Not entirely sure. Anyway, I'll take it out and clean it in hot water and see where we are with that. I just thought I'd show you the difference between where the handles were and the case. It's pretty manky, isn't it? I've had a quick go of everything here, just give it a clean up. It's either been a bit of washing up liquid just to clean these knobs and things up, and the case, I've had a quick go at it with the polishing paste number 5, and it does look a lot better than it was. Although I must admit someone else helped me polish this, 'cause I'm in a bit of a rush, but yeah, it's better, isn't it? It's interesting, I've washed the speaker grill in warm water and the washing up liquid, and it seems to have regained its shape, which is strange because I didn't think, well, I'm sure it's made of plastic. I just don't know. But anyway, so it's looking a lot better. well, that's the voltage selector cable replaced, although it's really a waste of time really. But of course it could cause a short the way it was splitting, so I've done it anyway, make it look a bit neater. I think the only thing I need to do is think about a fuse and possibly have a quick look at the alignment. The IFs are pretty well full of wax, 471 if I remember rightly. Interesting on this set that there's a medium wave loading coil for the aerial, which I haven't seen before. There's a second loading coil that's switched in for long wave, which I did expect. So it's 2/4 medium wave, so straight through the loading coil to the grid. But also the long wave coil is short circuited, that's interesting. And then on long wave 1 and 3, so through there extra capacitance through the loading coil and close that one. So you've got extra capacitance plus the extra loading coil on it. And C27 is the trimming capacitor for medium wave. I found there's an alignment mark here, so I just had to align that where it closes, and there's 1, 2, 3, 4 along here. That's the 4th mark, 3rd, 2nd, 1st. I just writ it out so I can understand. So Mark 4 is 600 kilohertz, yeah, that makes sense. Mark 1's 1.5 megs or 1500, so that's there. So it's, yeah, so Mark 3 comes into play there. So looking here, that's C29, that's C30, that's L4, that's L3, which has got to be accessed from the bottom of the case. L2 is the other side of it, on top of the chassis, and this is C27 from the rear hole. So this is fixed the chassis. Stick a bare screwdriver in there on a live chassis. Yep, that's very yeah, interesting, wouldn't it? That would be very interesting. Perhaps you're supposed to do it on battery. One thing that puzzled me is I can't see any reference to what Mark II is on the scale. So it says to use a small homemade coil, but I shall just use my loop I've got to do this. Well, after saying I'm not going to do the IFs, I've managed to get the wax out using some cotton buds and a bit of heat, so I hope I don't regret doing this. It's funny, it says L9, L8, L7, L6, sort of working your way back from the detector. But the thing is, the diagram doesn't seem to match the IF, so I'm a bit confused, but that's the second one, that's the first one. I'll see what I can do. It's a little bit offset from 471, not a lot, but I thought, oh, I'll just do it anyway. So 600 kilohertz I'm just doing, 600 kilohertz medium wave oscillator. Come on, got it. 1.5 megs trimmer. Just doing the 210 kilohertz now. So that's the oscillator. And then I'm going to have to see if I can shift this. Oh yes. Oh, that's quite an improvement there. Blimey. On the switch I've taken this Plaxon bit out that goes into the socket, and I've tried to get rid of some rough edges. I think it's okay now, so that's engaging. Disengage, and it has worked, so maybe it'll be alright, we'll see. Maybe a slightly stronger spring is needed here, but yeah, yeah, these two screws adjust the position as well, so that the contacts move over into the correct position when this is inserted. I've run out of small fuse holders, so I've had to put this fuse holder in for now. T160 milliamp, that should hold it easy. It's only drawing 100 milliamps, and of course you've got 400 ohms of input limiting resistance, so shouldn't be a problem there. I'm nearly done. I think I've just got to sort out this shaft on this pot, and I think I'll be ready to put it in its case and then do the trimming, and just hope that I've got a tool that will fit down through here okay, so that we can adjust the medium wave trimmer. What I've done is put some Aradite on the shaft here where it's a bit too thin, and now the knob is quite tight, so that's what we want. We don't want a knob falling off on a live chassis set, do we? Well, this is fun. To get to the medium wave trimmer, I've had to put a screwdriver slot in my trimming tool because it isn't long enough. There's a bung for the other capacitor, which is located down here, this hole here. So now I've just got to jog it between 1500 kilohertz or 1.5 megs and 600 kilohertz and see if I can get a peak. I think that's probably about it. Okay, quick tune round. Caroline comes booming in now on 4 kilowatts.
Okay. Some people.
Was on Sunday when City retained the Premier League title. So our
Aerial is very directional.
I had to be downstairs pitch side by 85 minutes. So I run along with City getting.
Try long wave. Oh, is that RTE? I don't know.
8 until later in Norfolk Sierra.
After trimming that long wave trimmer, it's so much better on Radio 4. Okay, so that's the Ultra Coronation 2. Nice radio actually. Not brilliantly sensitive, but I don't think a lot of these battery sets are. Interesting fact, I think it uses about 1.2 watts when it's on battery, and about 80 watts when it's on main, so it's certainly not going to win an Energy Star award, is it? But there you go. So yeah, I just wanted to get this done before the Jubilee comes up. Also, I've heard in the news that the BBC are shutting down all long wave and medium wave transmissions by 2027. So that's another interesting thing to note. Means we have an AM radio here. Anyway, thanks for watching. I'll see you soon.